Hello everyone, once again I'm Akimbola Kendi, and this is a follow-up video from where I stopped last week. This is week 3 and technically it's the 4th week. So I'm here to talk about a couple of things I learned in this last week. So we dived into the concept of solidity, and we always consider quite a couple of things. We learned about the data types, with respect to uint, boolean, addresses, strings, nouns and struct and the likes. And we're able to take a look at variables with respect to state variables, local variables, and global variables. And we learned about the differences between this concept, and also we taught about the structure of a contract, what makes up a contract, the elements that can fit into a contract. And we're also introduced into the remix environment before moving to our local machine to write our codes. And we looked into the concept of handling errors. So the concept of require, assert, and revert. Sorry. So and also we looked into visibilities with respect to state variable visibilities and local variable visibilities, such as the public, private, internal, external. Although when you were talking respect to state variable, we have 3, and excluding the external. So when we're talking about local variables, it's including the external visibility. And we also also touch state mutability too, with respect to pure and view. If you're dealing with view, that means that you can read from the state variable but you can't write to it. And then when you're talking about pure, that means you cannot read nor write to the state variable. So that's that. And we looked into the structure of a function, what makes a function, what makes it run, how it works. And we also took a look into the concept of interface and abstract. And also we touched aspect of storage, memory, and data. And during the course of the week, we were given a task to write a smart contract that that is similar to the ENS, such that you can subscribe to have a name with the .eth extension. And we did the whole logic in such a way that once a user already claims a name, no one else can claim the name. So I did this contract, and I'm going to show you how I went through it, how I did it, and I will explain my code shortly. And we also did a task on keeping student records, such that you can always go back to fetch the details of the student anytime you need it. All right, so I'm going to show you right now. All right, this is the task. To build a program similar to the way ENS works, such that if you input your name, you would be able to get the .eth extension that will be linked to your address. So if anyone sends money to maybe your name.eth, then the money, the coin or the token will reflect inside your wallet address you get. So it's like linking a name to an address, something like that. So when I send money to your name.eth, it redirects to the address linked to that name. Okay, and then a couple of functions that can add a new name, reassign a new name, delete from a list of names and stuff. So I implemented it using 2 mechanisms. I used the array to save my items, and map to look through the items, look for the names and stuff like that. And I used mapping to also map the name that is being assigned to the address. So let's see how this works. So if I deploy this contract, so if I input a name, so automatically if I do this. Let's bring this up. Yeah, transaction successful. And if I'm to check which address is assigned to that name, once I insert this name Kenny, by implication, the .eth extension will be attached to it, will be assigned to it. So now if I want to like get the address that is linked to this name, I'll have to like insert the name.eth and then get the eth details. So you see, we have kenny.eth and this is the address that is linked to this name here. That is this address here. I used to call that function. And if I decide to delete these details, I have to just provide the name.eth, and then the address. So this is the address assigned to it. Let me just copy this address here because that's the address assigned to this name. And if I transact, so now if I search for this again, it will bring 0, not because it has been deleted. And then I did something such that only the address that deploys this contract will be able to delete. Any other person won't have access to this function except the address that deploys this contract. So let's assign this name again, Kenny again, and try to replace the name. So Kenny again. If we check get details, we see Kenny.eth. Now if I try to replace the name with, let's say, Taiwo, and I click replace. Now if I try to search for Kenny.eth, it will not be mapped to that address. But if I search for Taiwo.eth, then the name has been changed and the address still remains. So if I try to get the total an address, a name detail with the index number, let's say index 0, then you should have like Taiwo at the first. And then let's say I have another another name, let me say Kenny here. So I assign the name Kenny. So Kenny will be there. If I try to get collection of index 1, it should bring Kenny. So that means we have two details inside the array. And then the way this this is built, if another user tries to get the name Kenny, it will throw an error saying that the name is not available. So that is how this works. And I use an array to create this. I created a modifier to confirm if the name has been assigned to anyone. So if it has been assigned to anyone, if the user already has a name, it's going to try and know that okay, this user has a name, you cannot get another name. Let's try that here. So we already assigned the name Kenny to this address here. So if I try to assign another name, let's say Chris, to this name that already has Kenny, to throw an error saying you already have a name. So that is what this modifier is doing here, which I included right here. This is confirm name here. So this is modifier right here. So this is what this modifier is checking over here. So basically it's going to just look through the array contents and then check for the name that is being passed. And then I can hash it in such a way that if the name here, the name stored in here, the Keka hash of the name stored in here is the same as the name being passed inside here, then it's going to throw an error that the name is not available. Get. And if what this one is checking is to check that if the user trying to get a name, if a name has been assigned to this address already, that means the person cannot get another name unless he or she uses the replace name function. So this is, I used the array approach to get this done. So okay, here's the function to get to assign an ETH name to myself to a user. So once the name is coming in, it goes through this modifier. Once it has the constitution is the modifier, then it pushes the result here. You concatenate the name that is being gotten from the user with the domain which I specified up here, and then it stores it inside this array, this array up here, array of struct up here. So that is the array approach, and I use the modifier as well, which worked exactly the same way. All right. So yeah, I used the mapping. I used mapping to get this done. So basically, I created a function, passing the name in here, and then there's something about mapping. You have to map a a key to a value. So over here, I'm mapping the string to be the key and the address to be the value. So over here, the trick I did just here is for me to check what is being mapped to the person trying to like call the function. So once I get what is being mapped, what this function here, this line here, it returns a name because this address is being mapped. This name here, the string name is being passed to this address here. So whatever happens here, whatever I get, what the resultant here, the result here will be a string, and then the string will be saved inside this scholar.name. So after it has been saved in here, I'll be able to like do with it whatever I like, such that me comparing it to an empty string. Now, the default value of a string is empty, like an empty string. So now, what this is trying to do is that if the name, the results I get from this place is a name, and then the data hash of the name is not equals to an empty string, that means that person already has a name. But if the result I get from here is an empty string, the empty string will be saved in here, and then the empty string will be passed in here. So now this require will now check if this empty string that is being passed in here from, that is by adventure the person has already assigned the name, this empty string being passed in here is equivalent to this empty string I specified up here, then it will go forward to like, map the name that is being passed, to like map the name up here, map the name down here, to the person that is calling this function. And now this require line is checking that to check if the name that is being passed does not belong to any address. So once it does not belong to any address, then it will go on to this line. That is what this function here is doing. And then this function, try to like do the same check to like check if it has been assigned to like replace the name rather. Sorry, and then also check if it has been assigned to someone, or this line of code ensures that only the owner of the name can replace this. So if it's not the owner, it cannot be replaced. Now this function deletes. It deletes. Once you specify the name you want to delete, so it does one or two check-ins. It does some check-ins, and it checks that whether you are the owner of the name, and if you're not the owner, you will be able to delete. But if you are the owner of the name, then it is going to like delete this. And then mind you, mapping does not have a function mapping does not allow you the user to like iterate through the items in the mapping. So you can't do that. So instead, as I'm adding the names up here, as I'm mapping the names up here, I am pushing the names into an array here for me to like keep track of the total number of names that are being passed. So over here, once I use the delete to delete from both the address map and the domain map, then I used the for loop to like loop through the array of names over here for me to like match the name inside this array here. Once I get the detail of this array, and then once this name plus the domain, concatenated with the domain, is equal to the name being passed here, which I saved in here, and I used right here. If it is equal, then it is going to pop that index. It's going to pop the whole that index itself, and then the remaining items in the array is going to shift. So now let's test this function, and it works just the same as the previous one. Say Kenny. So this assigns the name. So let's say I'm trying to like get the details of the name. So this is the address mapped to this name. So let's say I try to like check the name using the address as well. Paste it in here. Say brings kenny.eth. So if I try to replace this name, let's say I want to replace the name Taiwo. I want to replace the name to Taiwo, and I replace it. It should reflect, and if I try to check, it's going to like change immediately. So if I want to delete, so all I need to do is specify the name I want to delete, kenny.eth, and once I delete this item, if I try to query the address to bring an empty string because I've deleted the name assigned to the address. So if I decide to get the length, right now there is nothing here. So let me have the name Kenny back, and I try to get the length. Sorry. So let's sign the name. So now let me just try to get the length. See, length has increased by 1. Let me add another. Let me change the address and add another name. Let's see, please. So add this name. Add this name. So yeah, because I tapped it twice. So let me add this name, and then let me query increase.eth. So it brings the address, and if I get the length, it will increase to 2. So that is how this works. And the last one checks if to check to like the last second task looks stores a record of students. Stores a record of students. So it means deploy that as well. Now I made a constructor over here such that it accepts an address as the admin. So let me say this is an admin. So let me just copy this address. This constructor only runs once. So let's store this name. So Kenny then page 50 transact and get name Kenny. So it means return this. Now if I decide to delete Kenny, the details, I try to get the name Kenny, return until now the name does not exist. If I try to get count, it's gone already. Let me add these details again. Get count 1, delete, get count, that's 0. So and then I did a bonus task. Let's write a function that allows users to pay into a contract. This is just a bonus task. So try to take that. I just declared contract funding. This is just like keep track of the balance, the amount and stuff. So yeah, I made the function payable, and then I mapped the address to the amount that is being paid, such that if I provide the address as the key, it will return the amount the person paid into the contract. So if I deploy this, so then let's say this user wants to send 50 ETH, then pays fund. So 50 ETH gets into here, and if I want to keep track of the amount the address sent into, say, shows 50 ETH. So let me change this address and try to send 30 ETH from here. 30 ETH, then to pay fund. See, the amount increases, and if I check the amount the address sent, it should be 30 ETH. So there we go. So yeah, that's that. This new week, I look forward to learning a lot more about Solidity, and in the following week, I look forward to learn more things in Solidity. So after this week, I would come back next week to tell you all about it. Thank you. Bye.